So now how do we get from an agentic architecture like this into a production environment in a real enterprise? So we mentioned things like MCP, the Model Context Protocol. And we mentioned things like A2A, the agent-to-agent protocol. Now, when we take these things and put them into production, there is a big gap between where people are today, what the protocols offer, and what an enterprise production environment needs. So obviously you need security. So things like authentication, authorization. But there are new attack vectors that crop up when talking about agentic systems. Since these are natural language and emergent-based systems, we have to think about what's going into those prompts. How do we mitigate things like prompt injection or indirect prompt injections? So deep security guardrails around the communication patterns between the applications or agents, the backend tools, or even the LLMs. Now, we also need things like governance around what are the names of these applications? What are the names of these tools, these MCP servers, for example, that we're exposing? Because it's very easy for a malicious actor to come in with a very similar sounding MCP server and inject that into your application or make it available for you to consume. And you think you're using the financial reporting MCP server, but the finance reporting MCP server, which has a similar name, does all kinds of malicious stuff. Right? So we need governance around naming, governance around proving that those services really are who they say they are. So we need some sort of identity mechanism and verification mechanism. We need things like tracing, like auditability. Why did these agents make the decisions that they made? And at the moment, like I said, some of these protocols don't directly address these problems. Developers are kind of left on their own to try to figure that out. So in a production environment, what we need is something on the network or within these applications that can enforce and implement things like identity, secure naming, authentication, authorizations, tracing, and so on. So if we look at a potential environment here where we have an LLM and we have an agentic deployment here, we'll just call these A's for the moment. The first thing that we want to take a look at is the communication between the agents and the LLMs. Now, we've seen with microservices and previous web applications where we can implement a reverse proxy here that can take the traffic and send it off to the back end. But what we want to do is take a look at what those prompts are. And we want to enforce things like guardrails. We want to enforce things like rate limiting. We want to enable things like failover. We want to track metrics. Things like how many prompt injections that we maybe found, or how many times did we look up in a semantic cache. So caching is another thing we might want to add, and then tracing, like a open telemetry or distributed tracing solution. So this gateway right here, this AI gateway right here, needs to support those types of use cases when calling the LLMs. Now, when an agent is calling out to tools, they might be using the MCP protocol. And now this becomes interesting because the MCP protocol is a JSON RPC based protocol, and it is a stateful protocol. So when we want to expose, let's say, a set of tools as MCP servers to an agent, number one, we have to be careful about what those tools are. So we have to have a governance and curation process for what those tools are. And then when we expose them, we want to expose them in a way where we can control security and observability. And we can verify that any of the tools that are, for example, in the MCP protocol, we can list out the tools that are available and the descriptions of those tools, that they don't try to poison the context with some sort of indirect prompt injection. So if we have an intermediary here that can enforce that, like I said, authentication, authorization, guardrailing around prompt injections, and enforce the curation that no other MCP servers are injected into the network, then we can secure this MCP protocol. And at Solo, that's where we have the agent gateway, which can then be used for agents calling out to specific tools. Now, that's going out to the LLM, that's talking out into the enterprise, but one thing that we found when building agents is that you don't want to expose too many tools to an agent. You don't want to have the agent in charge of too many things. And so just like with a services architecture, we kind of want to scope them down, give them a limited set of tools, tighten up their system prompts so that they're really good at what that, one thing that it is they need to do. But then what you'll find is the agents, to get a longer running workflow done, will need to communicate with other agents. And that's where the A2A protocol comes into the picture. And just like MCP, or similarly to MCP, we need authentication, we need authorization, telemetry collection and tracing and guardrails and so on. And so that's where, if you don't do anything else, the A2A protocol does not support this. But at Solo, since we are a networking company, this is why we specifically, again, built the agent gateway, which does support the A2A protocol and the MCP protocols, and allows you to uniformly apply those missing pieces, those gaps, and solve those gaps, so that you can take an agentic architecture that communicates primarily over the network, and enforce the typical transport and API type issues that would crop up, but also take into account the natural language problems that crop up with AI model-based systems. So if you want to learn more about Agent Gateway or the AI Gateway, take a look at agentgateway.dev. Or if generally interested in AI communication and agentic systems, then reach out to us at solo.io.